you may recall last lesson we did a review of what sample space was and the different ways of drawing it. Now we're going to use that. So that's assumed knowledge that you know what a sample space is. So assuming all the outcomes in a sample space are equally likely, and an event is when you get an outcome that I care about, then the theoretical probability of an event occurring is this. The probability of an event E is the number of outcomes that correspond to E, and then divided by the number of outcomes in the sample space. So this relates to dice, for example. What is the sample space of rolling a normal six-sided dice? What are the possible options of that? What are they? 1, 2, 3, 4, 5, 6. Good. If the event that I care about is rolling a 6, how many outcomes on the dice correspond to rolling a 6? It'd be 1. So you'd have 1 over, and you just told me the sample space is going to have numbers 1 to 6. So how many numbers is that? It'll be 1 over 6. That's how that probability works, okay? What is this kerfuffle about, the equally likely? This formula is only going to work if that dice was fair, right? There's each one of those numbers on the side of the dice has an equal chance of happening. If, let's say, 6 was weighted, so it was more likely for 6 to hit the bottom of the dice and you'd have 1 on the top, this formula is going to fall down. It's not going to work, okay? So this formula only works, and we're going to make a lot of assumptions in this topic that the experiments we're doing are fair. This formula only works when the events all have an equal chance of happening. So with flipping a coin, heads and tails both have a 50% chance. Does that make sense? So this formula, the probability of an event, E, occurring, is the number of outcomes that correspond to E divided by the number of outcomes in the sample space. This little aside here, in probability, if we write P and then the E for an event, but with an apostrophe above it, that means the probability of an event not occurring, okay? So this is the default. This is the probability of an event occurring. If I write probability E apostrophe or E dash, then we're talking about the probability of an event not occurring. So on a six-sided dice, if the event that I cared about was rolling a 6, it would be 1 over 6. But if I said the probability of not rolling a six-sided dice, would it still be 1 over 6? It would be 5 over 6, right? Because that's the opposite. That's the inverse of what I was caring about. So let's have a look at this one as a first example. I'll give you time. Suppose that 3 coins are tossed at the same time. List the sample space. Have a look at your notes from previous. What did a list look like? What was special about a sample space that was a list? Yes? Curly brackets. So we'll put our curly brackets there. Was that a fart? That was a chair. Okay, what are the flipping 3 coins at the same time? Is there a systematic way that we could do the results of flipping a coin 3 times rather than just you throwing out a bunch of randoms and us losing track? Let me get you started. Is that a possible result of 3 coins tossed at the same time? Could I get heads, heads, heads? Yeah. Let's think of it. Someone throw out something. Anything?
Heads.
Next, something else? This isn't this. Sorry?
3 tails.
Okay, this is not systematic. I would have thought that you'd scan from left to right, but whatever. As long as we get 8. There are 8 results. And another one? Sorry? TTH. Okay.
Tail, head.
Next. 3 more. 2 more. Come on. This is awkward silence in the YouTube video. Yep. And there's another one that starts with head. Have you had 2 heads yet? Have we had head, tail, tail? Oh, no, yeah, you're right. Head, tail, tail. That's that? Okay. So there's 8. The sample space is 8. So B, what's the probability of getting 3 heads? So how do we write our answers to this? Probability 3 heads is how many of these events correspond to getting 3 heads? 1. Only 1. So what's the top of my fraction going to be? 1 over, what is the whole sample space size? 8. Done. You leave it at that. You don't need a calculator or whatever. Keep it exact. That's 1, 2, getting at least 1 head. So this one, you have to think about it. At least 1 head. How many of these correspond to that event that I care about? Is that at least 1 head? 1? Is that at least 1 head? At least 1 head? No, so we're at 2 right now. At least a head. 3, 4, 5, 6, 7. So that's going to be 7 over 8. I'm going to give you a couple of minutes to get that example down of finding the theoretical probability using a list. If you've got the purple example, maybe start writing example 2, the custom dice. So our second example here, I need to show you how we find probabilities using a grid instead. So I've got a custom dice here. The sides are numbered 0, 0, 1, 1, 4, and 5. So it's not a plain dice. It's still fair though, because it's a 6-sided cube that I roll. It's just the numbers are different, okay? So it's still fair. Our maths is going to work. It's just not the 1, 2, 3, 4, 5, 6 dice that we've got. And you're rolling it twice. Draw a grid to represent the sample space. There's my grid started off. But what was the point of a grid? A grid is when there's 2 aspects to the experiment. What are the 2 aspects in the experiment of this dice? I roll it twice. So I don't really care about the order you do it in. It's not going to matter. Roll 1, roll 2. For roll 1, what are the possibilities of that dice that I roll? 0, 0. Next. 1, 1, 4, and 5. Is it the same for roll 2? Doesn't say that I'm grabbing a different dice. 0, 0, 1, 1, 4, 5. What is it about a grid? There's dots for all of the possible results. So there's going to be 36. 6 times 6 here. The trick here is finding the events that you care about. So B1, probability getting 5 total. Not just getting 5 on the dice, 5 total. So you need to add. Does this get 5 total? Because that's 5 and 5, that's 10. I'm here. This is where my laser is right now. Someone tell me, where do I aim? Left and right, up and down. Where do I go to get the first result of 5 total? 4 and 1. So here, is that fair? Is that 4 and 1? That's going to total 5. So I'm currently there. Where else could I circle? How many other 4 and 1s are there? There's a few. There's another one there. 1, 2. Where else is there? 3, 4. Is there other possibilities of getting 5 here? 5 and 0. 5, 5, 5, 5. Am I missing anything? Is there any other ways? Good. So probability of getting 5 total. 1, 2. How many things did I circle? 1, 2, 3, 4, 5, 6, 8 out of, what was the sample space? 36. Done. You're not done quite yet because that's cancelable. It's an even number. 4 over, is that 18? And then 2 over 9, not cancelable. 2, probability getting 2 same. I'm going to use blue this time. 2 same. 0, 0. 0, 0, 0, 0, 0, 0. 1, 1, 1, 1, 1, 1, 1, 1. 4, 4. 5, 5. Is there anything that I'm missing there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's going to be 10 out of 36. 5 out of 18. Some minutes, please. Can you get the grid example down? Go. Looks like a bird. Oh. Wow. Ignite. For this test, do you guys mind if I use names in your test? Like topical? You're not gonna get all butthurt about it. Because that's why I started using Kanye. Because people were like, oh, what was my name on the driving question? Yeah, they did. They complained. At risk, you know? At risk of playing Chang-Zi. Okay. There's only 2 more.
There's 2 more?
Yep. Example 3. There's a library. There's a group of 50 readers. 31 like science fiction. I like to highlight the important information. 50 readers, 31 science fiction, 20 detective stories, 12 dislike both. Shh, girls. Draw a Venn diagram to represent this situation. So something you learned last time, there's a rectangle around to represent the universal set. There is not one set of steps to work this out. Let's logic it out, okay? So the universal set is on the outside. Which one would you like to represent science fiction? Which circle? The left one, let's go SF. And the other one would be the detective stories. Obviously the middle is people that like both. But we're not told how many people like both. We're told how many people dislike both. So the only thing that I can enter here that I know straight away goes in where? U, SF, or DS? Which of those 4 things have I highlighted that I could enter straight away? The 50 readers? I don't know where that 50 goes. Do I know... Which one? Any? Do I know how many dislike both? 12. Where would they go? In U? Okay. 12. Good. We need to work out. There's no set of steps here. But I know the total is 50. And I've just put 12 on the outside. So how many people should be within all 3 of those areas? 38. That's how we logic it out. Okay? And then the way I personally do this, there's some people, especially because I teach Ignite, some people just get the answer straight away. I'm not like that. I do working out. I don't get to the answer straight away. So the way I do it is I do it wrong to start off with. Okay? How many people does it say like science fiction? So I write 31 just under here. And how many people like detective stories? 20. 31 plus 20, what is that? 51? That's too big, isn't it? That's bigger than 38. So what do I do between the 51 and the 38 to work out how many people go in the middle? Minus it. So what's 31 minus... 51. 51 minus 38? 51. I suck at subtraction. 13. So 13 should be in the middle. And now that I've got 13 in the middle, what do I do with that 13 and 31 here? Minus it again, because I'd taken 31 of the people that like science fiction that was wrong on purpose. So 31 minus 13, that's going to be 18 there. And take 13 from 20, that's going to be 7 there. Now I double check and I go, are there 20 people that liked detective stories according to this Venn diagram? Are there 31 people that liked science fiction according to this Venn diagram? It doesn't tell me how many liked both, but we just worked that out, didn't we? Okay, so using maths, using some logic there. And yeah, it feels weird to do it wrong on purpose at the start, but I didn't have that information, okay? So draw a Venn diagram to represent B1. If a reader is randomly selected from the whole group, what's the probability that they like science fiction and detective stories? So probability like both. How many people like both? 13 out of, we're choosing from the whole, 50. Just to buy one, we're not up to this yet, but what if it said, how many people like both out of the people that like science fiction? Would it still be over 50? It'll be 13 over 31. Yeah, good. 2, probability likes either SF or DS. What does either mean in this case? What am I saying when I say either? What does the question say then? Likes one of either. They only like one of them. Good. So we're not talking about all of these people. We're talking about that, the 18, and the 7. We're not caring about the people that like both. So 18 and 7, that's going to be 25. Over 50, that cancels to half of the people like either one or the other. All right? A few minutes to get that one. There's one more example, which is reading a table. Then we're sorted. If you have that example, start getting the last one. All right, let's have a look at the last one. I'll try to keep that up there so you can see it all. The table below shows language studies by people studied by people at a language school. What's the probability that a randomly selected person from the school is female, is studying French, is male, but not studying German? You could try to work that out now, but can I encourage you to find some totals first? Add on to this table. So if I extend this out, and there's going to be a final total there. If I was to add 14 and 18. What is that finding? 14 add 18 is how many people do? Good. 15 and 9. How many people do? So this is regardless of the... Okay, we're in 2025 now. So sex, there's 2. Gender, whatever, man. So Italian, what happens if I add 11 and 16? 27. What's happening if I'm adding 14, 15, and 11? What is that telling me? Good. And what is it doing when I'm adding 18, 9, 16? That's females. And what is it doing if I'm adding everything? 14, 15, 11, 18, 9, 16. That's just everyone at the school. Please notice that, 83. Please notice that the total of this column is going to be 83. The total of that row is also going to be 83 if you've done it right. Why is it useful to do the extension? Because that helps me answer the questions quicker. What is the probability a randomly selected student from the whole school is female? P, female. What number am I going to use for the top? 43 over how many people are in the school? 83. That's not going to cancel. You leave it. A, B, studying French, probability French. What number am I going to use for the studying French? 32. Can you see why the table is useful to extend it? 32 over 83. That's not going to cancel. 83 is not a nice number. Lastly, P, male, but not study German. This one, we don't use 83 because that question saying male limits us now. It's not going to be over 83. Is male but not studying German. So what's my bottom number going to be? 40. And how many of them are not studying German? 14 and 11, which would be 25. That's going to cancel. 5 over 8. That's it for today.